Hi, welcome to my Computer Science Chapter 2 CET. This chapter focused on the Internet Protocol stack, how it works, its functions, and what contributed to this. So it has abstractions, so this layer can use these two layers without knowing how those layers work. An example would be HTTP followed by TCP/IP and then the physical internet. We're going to be focusing on the Transmission Control Protocol, or TCP/IP layer. First, how does this work? Well, it takes the message and it breaks it down into blocks of information called packets like so. Then it numbers them so they can be used for reassembly. Then they assign the to and from addresses, so I could say to Miss L from me. However, these would have assigned IP addresses. Now that you know how this works, let's take a look at why it even matters. Well, suppose this question were to come up. Which of the following is not true about TCP/IP packets? With the following answer choices. A. Packets are numbered so the message can be reassembled at its destination. B. TCP guarantees that no packets are ever dropped. C. Packets can be routed on different paths from sender to receiver. Or D. Messages are broken into packets to improve reliability of the internet. So which is it? First, let's take a look at answer choice A, which states that the packets are numbered for reassembly. This is true, but why is this true? Well, we know that TCP specifically breaks down information into packets and gives them an order number, thus resulting in being easier to reassemble them at their destination. So, this is true. Next, let's take a look at choice B, which says that TCP guarantees that no packets are ever dropped. Well, while it is true that it always makes sure that all packets are always sent, it is not impossible for a packet to be dropped, because if it is dropped, the packet will just be resent by the TCP, so therefore this is false. Finally, let's take a look at choice C and D, which are both true since the TCP breaks messages into packets, numbers them, which creates trustworthiness of the transmission of data. Next, the data can be sent over multiple routers and still get to the same destination, which defines the internet being redundant or fault-proof. Therefore, since these are both true, we can eliminate C and D. In conclusion, we now have eliminated A because it's true, and C and D because they are both also true, and we are left with B, which is false, so B is the correct answer. Let's review. So, the TCP, first it takes this message, breaks it down into packets, then it numbers these packets for assembly. Then, they assign the to and from addresses, which are then routed through many different routers to all get to the same destination. Bye, thanks for listening to my CET.